Alright, in this video, I want to show you how to graph sine curves, also known as sinusoids, which is any transformation of the sine function. We're going to have a general form for our formulas, and if we're dealing with a sine curve, the form is going to be this, and if we're dealing with a cosine curve, the form is going to be this. If the data starts at the midline, we're going to use sine. If the data starts at a maximum, we're going to use the cosine. Notice that we have four constants, A, B, C, and D. And A can never be 0 and B can never be 0. C and D can be zeros, but not A and B. Otherwise you wouldn't have a sine function. What does A do? A changes the amplitude. And we'll talk about how when A is less than 1, the curve is going to get compressed. When A is bigger than 1, it's going to get expanded. If it's negative, it's going to get reflected. Main thing to remember from here is that if A changes from the original value of the original curve, which is 1, your Y values are going to change. So A affects the amplitude, which in turn affects your Y values. B is the one that's right in front of the X. B is going to affect the period of your graph. When it's less than 1, it's going to expand it. When it's greater than 1, it's going to compress it. And I'm going to show you on a website, Desmos.com, what I mean by compressing, by expanding and compressing. And then I'm also going to show you when I do the pencast, how to find your X values. Remember, if B changes, because remember the original B is a 1, if B changes, it's going to change the period, which in turn is going to change your X values. So things to keep in mind: A changes the Y values, B changes the X values. Alright, let's go to graphing. So let's say this is a website, Desmos.com, and I'm using their calculator. Let's say that I graph the original curve, sine x. Well, from this we can see that the value in front of the sine, the A value is a 1, and the value in front of the X, the B value, is also a 1. This is our original graph. Put it on projector mode. Let's get some pies going. Now, it starts at the midline of the graph and then it goes up and down. This is one period, 2 pi. It's how long it takes for one full wave. So we end at 2 pi. Well, what happens when we change the A value? So let's say that I say 2 sine x. What happens there? Well, you can see that it's still starting here, but that it's going much higher. In fact, it's going all the way up to y equals 2, whereas originally it only went up to y equals 1. So what's happening here is that the curve is getting pushed up. It's almost being expanded vertically. It's not moving. We're still talking about the same x values. The period is still 2 pi, right? But it's longer. Same thing would happen if I say y equals 3 sine x. You would expect it to become even taller. It goes all the way up to 3. Right? So when A is greater than 1, the graph is going to expand. What happens when the graph is less than 1? So what happens when it's 1/2 sine x? Well, it's going to be half of the original curve. You see, it only goes up to 0.5. See, negative 0.5. So what's happening here is that the amplitude is not changing the x values, it's changing the y values. If it's bigger than 1, it's going to make it taller. If it's less than 1, it's going to make it shorter. Alright, so that's A. It changes the amplitude. Oh, just to emphasize, the amplitude is the midline to the peak. So here the amplitude is 0.5. To the original curve, the amplitude is a 1. Greater than 1 is going to compress it. Less than 1 is going to compress it. Greater than 1 is going to expand it. Negative. Alright, what happens when it's negative? Let's go ahead and clear this. Let's plot the original curve, y equals sine x. So what happens when we have a negative sign in front? Y equals negative sine x. You see what happened? Oh no, it changed everything. Where are my pies? There we go. Let me make it bigger. So what happened? The red is the original curve. The negative sine x is the blue one, and it got flipped. It gets reflected on the x-axis. Same thing, if you have y equals 2 sine x, see that's the green one. Well, what happens when I have negative 2 sine x? That's this purple one right here. So it's the reflection of the green one on the x-axis. Alright, so now let's talk about b. B is y equals sine 2x. Whoa. Alright, the original one is the red one. Starts here, up, intercept, minimum, and then touches over here. That's one period of the original y equals sine x curve. Okay? So what's the black one doing? The black one starts at the same point. It peaks, intercepts, that's the minimum, and then reaches here. But the red one is not done. The red one is still one full period here. And then you get another black one here. So it looks like we got two black waves. 1, 2, in the same distance where we only had one red one. So what is the 2 doing? The 2 is causing you to get two waves in the same space where you normally get one. It's compressing the curve. It's cutting the period in half. The period of the black one is now just half of the original curve. See, the original period was 2 pi. This black curve rises and falls and comes back to regular pi. So its period is half of the original one. So what this is doing is it's cutting your period in half. If I put a 3 here, that means that I should get 3 curves where I originally only had 1. Alright, the red one is the original curve. So how many black curves do we get here? We get 1, 2, 3. So now we have 3 curves where we normally would have 1. So it cuts the period into thirds. And if we have a 4, you can expect 4 curves. 1, 2, 3, 4 in the space of the original curve. So it cut the period into fourths, or a quarter of the original size. So what happens when we go less than 1? So let's say this number is 1. Don't do this. 1/2 of x. Well, let's see if we can analyze this. The red is the original period up to here, but if you look at the graph of the black's not done. It hasn't even gone down yet. It's not done up to here. Well, at that time we've had 1 full original, 2 original waves. So what does the 1/2 do? The 1/2 means that you need 2 original waves, the distance of 2 original waves to make the distance of the new one. Or basically it elongates the period by a factor of 2. So if we put a 3, that means we need 3 original waves, or the distance of 3 original waves to make the black curve. Now I'm going to have to zoom out because it's not enough space. Alright, let's see, the black one starts here, up, down, and it doesn't end over here until 2 pi. Let me get rid of these extra points. Doesn't end here until 6 pi. Well, how many original red curves have we had? Let's see, 1, 2, 3. So the 1/3 means that this curve, the period is 3 times bigger than the original period of the sine x. So our y values are different, where it's peaking, where it's crossing, where the minimum is. Our x values are different. Now notice that the y value remained the same. Why did the maximum and the minimum remain the same? See, the maximum here is a 1. Because we didn't change the amplitude. If we change the amplitude, let's say to 2, the graph will be twice as big. If we change it to 3, the graph becomes 3 times as big as this one, because the amplitude changed from 1 to 3. If we make it 1/2, then it would be half the distance. See, this one goes up to 1, this one only goes up to 0.5. So this is the type of graphs that we're going to do, and make sure that you watch the pencast.